Very good morning to all the students to be present there. Now we will discuss today's the dynamics of electric drive. Up till stage, you are covered. What do you mean by this industrial drive? What are the various components of industrial drive? And in case of an electrical industrial drive, we are using electrical motor as a prime mover. So what are the various criteria for the selection of electrical motor in case of electric drive? These are all we discussed in our previous lectures. Now, today we are come with the dynamics of electric drive. Dynamics of electrical drive means now we have to perform certain operations. Under certain operations, we have particular area of applications, and you have to discuss all the particular area of application that how in particular application that your drive system can work. Okay. So before discussion about the dynamics of electric drive system, I will tell you for examination point of view, this is one of the most important topic. If your exams will be on offline mode, then there is one question that is called as fourth quadrant operation that I will discuss with you people shortly. This is the most important question, and it covers 20 marks question in final exam. But if your exams are still in online, then this question is also included in your online examination also. So you can say that this topic or this chapter is basically the most important topic or the most important chapter in case of electric drive. Now here you have to discuss that what do you mean by this dynamics of electric drive. So by the time we know that electrical motor is the main component of the modern variable speed drive, because we are dealing with the electrical motor drive system, and you all know in drive system basically there are three types of components present. One is called as prime mover, another is called as the transmitting device, and third is called as the load. So when the motor will start rotating, the transmitting device is also start rotating, and hence the load will start rotating. So you know that the prime mover is basically an electrical motor. So that is why we can say that electrical motor is the basic component of the modern variable speed drive. The electrical motor, as we all know, it is a machine that converts an electrical energy into mechanical energy, and the mechanical power output of the motor is proportional to the product of torque and speed. So you can say that what type of output power you can obtain from the motor, because a motor is a device which converts electrical energy into the mechanical energy. So at the output of the motor, we have a mechanical energy, and this mechanical energy is basically proportional to the torque and the speed. Torque means turning effect, and speed is rotations per minute or rotations per seconds. A part of torque is lost is in friction. As we all know that in order to reduce the friction, we are using various types of gadgets like ball bearing, general bearings, and all that. So a part of torque is lost in friction. So an understanding of the mechanical aspect necessary to grasp the working of an electrical drive. So in this chapter or in this topic, we will study that what are the various types of load that occur in our drive system, how this drive system can work, and what is the area of application of this drive system. Okay, so you see types of load. In electrical terms, load means the component which conserve the electrical energy to do the useful work. So according to the electrical, you can say that drive system, the loads are basically classified into number of ways. Number one is according to the electrical phase, the load can be divided as a single phase load or a three-phase load. According to the consumer category, the load will be industrial load, commercial load, or residential load. According to the electrical load unit, load will be in kVA, load will be in kW, load is in HP. According to the nature of the load will be resistive, the load will be inductive, and the load will be capacitive. So I can tell you all these things you are discussed in your previous semesters, that depending upon the supply, depending upon the output, depending upon the electrical load, depending upon the nature load, we are classify the load in different categories, and these all loads are included in the drive system. So that is why depending upon the supply, the load can be classified as a single phase load or a three phase load. You all know what will happen in case of a single phase. In a single phase, there is one line and one neutral. So the voltage between line and neutral is called as the phase voltage. And at that time, the current will flow. That current is basically called as the phase current. But if you are using a three-phase load, so in that case, there are, instead of one phase, there are basically the three phases present. That is R phase, Y phase, and B phase will be present. Okay. So when you take a three-phase load, in that case, there are basically, you can say that there is a term that is called as the line voltage. There is a term that is called as the phase voltage. I request to please turn off your mic. I request to please turn off mic. Whose mic is turned on? Fine. So you are discussed about in basic electrical engineering in third semester. You are discussed about in machines that we have a single phase load and we have a three phase load. The only difference in single phase load and the three phase load is that thing. In case of a single phase load, you have one phase and one neutral, and the voltage between the phase and the neutral is basically called as your phase voltage, that is a VP, and the current flowing at this time is called as the phase current, that is IP. Whereas if you talk about the three phase load, instead of one phase, there are three phases to be present, that is R phase, Y phase, and B phase. So the voltage between any two phases, like R and Y phase, like Y and B phase, like R and B phase, that voltage is basically called as your line to line voltage. And in that case, the current that flows in the circuit is called as the line current. You should also know that in case of basic electrical, we are discussed about the connections of three-phase supply. You remember, in case of three-phase supply, you have two types of connections available. One is called as a star connection, another is called as delta connection. So what do you mean by star? Star means where phase voltage is equal to line voltage upon √3, and the phase current is equal to line current. And in case of delta connection, your phase current, that is IP, is equal to IL upon √3, that is phase current is equal to line current upon √3, and your phase voltage is equal to line voltage. So depending upon the nature of the supply, whether you have a single phase supply, whether you have a three phase supply, so accordingly we can distinguish the load. That load may be a single phase load or load may be a three phase load. So this is the first category, that according to the supply, we are classify the loads into two categories. One is called as single phase load, another is called as three phase load. So this is the first category. Now, if I talk about the second category, depending upon the consumer terminal. So according to the consumer terminal, we have classified the load into three main categories. Number one will be industrial load, number two will be commercial load, and number three will be the residential load. Now, the industrial load means all the industries, they are located at some distance away from the populated area. In case of any industry, what we have to do, we have generally production will be there, manufacturing processes will be there, refining process will be there, and all that. And these industries can consume a lot of amount of power which are generated or which are received from the grid station. So the motors which are employed in these industries are not a single phase motor, they are basically the three phase motors, because due to the heavy capacity load, due to large ratings, so we are employed a three phase motors to be there. So when you employed a three phase motors to be there, the three phase motors draws a lot of current, they can use a lot of voltage. So accordingly, the load which are used in industry are come under the category of industrial load. Okay. In the same case, you have a commercial load. Commercial load means we have a big malls to be there, we have big grocery stores to be there, we have something, you can say that shopping malls, some you can say that a very big restaurants to be there, hotels will be there, and apartments will be there. So all these categories are under the categories of your commercial load. So commercial means commercially we can use the electricity power. So this type of load comes under the category of the commercial load. And number 3 is called as the residential load. So residential load means the load which are you people and I people were using in our we can start homes, and that load is basically called as the residential load. So one point here you should kept in mind that the industrial load, the commercial load, or the residential load, these loads are may or may not be a single phase load or a 3-phase load, but only and only your residential load, that the residential load is a single phase load, whereas your commercial load as well as your industrial load is maybe a 3-phase load or a single phase load. But generally preferably industrial load, but we have industrial load as well as commercial load are a 3-phase loads, whereas your household household loads are basically the residential load, and these are single phase load. So accordingly, the service required, we are classify the loads as industrial, commercial, as well as the residential load. So here you should kept in mind the one point that industrial load and the commercial load are basically the 3-phase load or maybe a single phase load, but your residential load is maybe only and only single phase load. So here you should be remember that if you adopt a drive in industry, so the requirement is 3-phase. So that means you are using a 3-phase electrical industrial drive to be there. And for 3-phase electrical industrial drive means the prime mover is an electrical motor. It is of 3-phase type. So accordingly, we can adopt the drive system. So that is why we are discussed that depending upon the load, we are designed, we are formulated, we are get erected a drive system. Okay. Number 3, according to the electrical load unit, we all know in case of an electrical, there are 3 types of power available. One is called as active power, another is called as reactive power, and third is called as apparent power. So active power is basically you have VI cos phi, that is the product of voltage into current into the power factor. If you talk about the reactive power means VI sin phi. And if you call it about apparent power, then apparent power is only the product of voltage and current. So you can say that if you multiply the phase voltage and the line voltage with the power factor, then the power so available is called as your active power. And similarly, we have a reactive power and we have an apparent power. So depending upon the power, we are classify the load in kVA, we are classify the load in kW, and we are classify the load in HP. For example, you all know the transformer which are used as a step-up transformers in case of generating stations. The same transformers can also be used as step-down transformers in grid station, and moreover, the transformers can also be used in our household in order to increase or decrease the voltage. So we know that the rating of the transformer is in kVA. So that is why the load in case of drive system is in kVA. On another hand, if you take for example your another you can say that load, like you have a bulb to be there, you have a tube light to be there, you have more cooler to be there, and all these loads are having a capacity or having a power rating in watt, and the bigger unit is in kW. So that is why the second load will be classified into kW load. Whereas if you talk about the industry, if you talk about the commercial, we are using a motors, a big capacity motors, a high rating capacity motors. So in that case, the rating of the motors in HP, that is in horsepower. And if we all know that 1 HP is equal to 735.5 kW. So accordingly, the rating of the motor can be selected. So you can say that depending upon the electrical load unit, the load will be classified into 3 main categories. That is load in kVA, load in kW, as well as load in HP. So this is the third classification of the type of the load under power. The fourth one and the last one is according to the nature of load. We all know in an electrical, there are 3 type of elements to be available. One is called as resistance, another is called as inductance, and third is called as capacitance. So accordingly, we have a resistive load, we have a capacitive load, and we have an inductive load. You all know in our previous semesters, like in 4th semester, in 5th semester, and 6th semester, you are discussed about that in case of resistive, there is no lead or no lag in the current, or you can say that in case of resistance, the power factor, that is the PF, is equal to 1, because power factor means the cosine of angle between the voltage and the current. And when you have, and when you talk about the angle between the voltage and the current, the angle between the voltage and the current in case of resistive circuit is equal to 0, and hence the power factor is equal to 1. But if I talk about the capacitive as well as inductive, the current as well as the voltage are in lead or in lag in case of inductive or a capacitive. Like you remember, in case of inductive circuit, current lags voltage by an angle of 90 degree if it is a pure inductor. But if it is a pure capacitor, again the voltage and the current are out of the phase, and in that case the current leads the voltage by an angle of 90 degree. Only difference is that thing, the lead and the lag angle remains same, that is a 90 degree. But only and only difference is that thing, in case of inductor, current lags, in case of capacitor, current leads. So accordingly the power factor is changing. In case of inductor, the power factor will be equal to 0. In case of capacitor, the power factor will be equal to 0. But in case of resistor, the power factor is equal to 1. So as in electrical, we have only the three elements to be present there. One is resistor, another is inductor, third is capacitor. So accordingly, the power factor is always and always ranging from 0 to 1. But it is neither 0 nor 1. The reason being, if it is 0, that means the circuit is pure resistive. Sorry, the circuit is pure inductive or capacitive, which is not possible. Or if it is 1, that means the circuit is pure resistive, which is again not possible. So ideally, we can say that the power factor is range from 0 to 1, but it is neither 0 nor 1. It is ranging from 0 to 1. And why I'm focusing this power factor into this category, that is according to the nature of the load, because when you have low power factor, then the efficiency of the system is also reduced. Like efficiency, I talk the rating, you are using a motor in case of industrial load, you are using a motor in case of commercial load. So when we have a low power factor, the efficiency of the motor is also drop. So you have to increase the power factor. So when you increase the power factor, the efficiency is also increasing. So in order to increase the power factor, we are using a various circuits, like we are using a pure capacitors, we are using the condenser circuit and all that. So depending upon that thing, you are saying that low power factor causes low efficiency of the machine, and we have to improve the efficiency of the machine. So accordingly, you can say that the nature of the load will be classified as resistive load, the inductive load, and the capacitive load. Okay, so this is all about the various types of load that occur in a drive system. Okay, ji. So now in my next lecture, we are discussed about the dynamics of motor load system. Now what we have to do, now we are basically, just a minute. Now what I have to do in next lecture, I am coupling a motor and a load, that is a drive system, and we are formulating a certain, you can say that equation, and we can solve this equation. Okay, so anybody having any doubt related to today's lecture, now he or she can ask me now. Is it clear that what are the various types of load occur in the electric drive system?
Yes, sir. Yes, sir. Clear.
Okay, fine. So this is all about for today's lecture. So we will cover next on next lecture. Okay. Just a minute.
Okay, sir.
So it's the time for your attendance. So I am sharing the link of Google form for attendance purpose in a chat box. So you are all requested to mark the attendance on the Google form link provided in the chat box. And those who are marked their attendance, they can leave now. So, but before leaving this Zoom platform, make sure that you have marked your attendance. Okay.